Okay. Here's my virtual machine. I need to get the PDF up, so let me pause this while I get the PDF up. Okay. Hold the PDF up. So it says assignment 2, linked list. Submit your code files and answer questions 1 and 2 to Blackboard under assignment 2 by the due date specified in Blackboard. Plan to demonstrate your working program to the instructor in class after the due date. Question 1 is given a singly linked list. Find the middle of the linked list. For example, if the given linked list is 1 to 2 to 3 to 4 to 5, then the output should be 3. If there are even nodes, then there would be 2 middle nodes. We need to print the second middle element. For example, if given linked list is 1 to 2 to 3 to 4 to 5 to 6, then the output should be 4. Now with this, I'd like to note that the decision for like the even case is arbitrary. Like you could either do like the first one or the second one. So like in this case, you could just as well say it's 3. So, but once you make that decision, then you should be consistent. So we're going to say if there's 2, then output the later one, because I guess you could output both of them. Or maybe you could like take the average of them if they were numbers or something. It's kind of, I think if you're calculating the median, it's the middle number, but if there is no middle number, then you take the average of the middle 2 numbers. Or for example, if you had like 1 to 7, I think the middle would be, well, let me draw an example. So like if there's 1 to 2, 3 to 4 to 5 to 6 to 7, here the middle would be 4 because there's 3 on the left and 3 on the right. And then if there is 8, the middle would be, here's the first 4 and then here's the second 4. And so the middle 2 are 4 and 5, and then we take 5. Okay, so let's take a look. Find middle. Okay. So this one, I'm using like an algorithm. So I have a slow moving thing that moves 1 step at a time and a fast one that moves 2 steps at a time. And while the fast one hasn't reached the end of the list, and the next one for the fast one isn't. So let me explain how this works. So say we have this. So the head is 1. So head equals 1. Head equals 1. So that means slow equals 1 and fast equals 1. Okay, now fast is not equal null, and okay, 1 dot next is 2. That's not null, so we keep looping. So slow, we go to the next one. So slow equals 2, and fast equals 1 dot next dot next. So that would be 2 dot next, and that would be 3 dot next. That would just be 3. Whoops. Okay, so now we have slow equals 2 and fast equals 3. So slow moved forward 1. Okay, now slow is going to equal 3 and fast is going to equal 5. Still haven't reached the end. Slow is going to equal 4 and fast is going to equal 7. Okay, so now fast does not equal null, but the next element with this one is null. So that's going to break, and what we're going to return is what we have stored in here, slow, which is 4. And that's right. So I walked through this example. Now, if it was the even one, we would do it like this. And now we would have slow equals 5, fast equals well, wait a minute. Wouldn't that cause an error? Because it's like, yeah, right now I guess fast would be null. Okay, so fast is now null. Okay, now it's going to check, is fast not null? No, null is equal to null. So now it's going to return 5, which is the correct answer for this. Okay, so that's working. So I demonstrated that I have an understanding of that algorithm by walking through that example. Okay, question 2, write a pseudocode for a function that clones the linked list by taking a singly linked list and returning a complete copy of that list. And one of these programs, I have it where I have like a test where what it does is it modifies the list to see, because we want a deep copy. Yeah, here. Okay, I'm just gonna quit. Okay, so we have 1 to 2, 1 to 5, and then the middle element is 3, and then we have 1 to 5. Now we've cloned it. Now, we don't want the copy to be affected by changes to the original list. It should be an independent copy. It should, so we modify the original list, and now it's not just 1 to 5, it's 1 to 6. But the clone list is still 1 to 5. So I guess you call it like a deep clone or something, as opposed to like a shallow clone or something. Like I think in Python, something with indexes, like depending on how you use slicing, you might think there might be some weird behavior because like it's a shallow clone. It has to deal with like the difference between when you pass a value by reference and a pass a value by value into a function. So anyways, there's that. Okay, and then the code for that is this is just printing stuff that doesn't have the code for that. Should be here. Clone it. Okay. So if it's just an empty list, then we're just returning null. So we're going to create a new linked list. So what we're doing is we're kind of creating a custom implementation of the linked list. Like Java already has an implementation of linked list as a class in like its data structures, I think in the util thing. Okay, so copy the head and then just, well, let me walk through an example here. So say there's the, okay, if the head is null, well, the head is not null, it's 1. Okay, but if we did just have like that, then we return null. Okay, so we're creating a new linked list, and so far we have 1 for current original, and current clone is null. Okay, and then the clone list head equals a new node with the data in the current original. So the head is 1, and the data in, okay, so the clone list current head is 1. And then the next one becomes 2, I think. So the head of the new list is a new node, and then this is what we're going to return. We're going to return the cloned list, and then this current clone is like tracking the individual element within the list, and this one is tracking like in the list that we're copying it from. And so it's saying like, while the one that we're copying from has a node that's not null, so while we still have nodes left to copy, what we're going to do is basically copy it, and then we return it. Okay. Okay, so here's some skeleton code. The coding assignment details the following skeleton code Java is provided. Homework linked list, private class node. So the node stores data and it also points to the next thing. And then a node, that's just a constructor, a getter. So, okay, then we have head. So I think these braces, it's kind of hard to tell. Okay, those. Trying to see how these brackets match up. Hopefully I can copy from this. Select text. Wait. Well, let me delete that. Hold on. Delete. Okay. Create a new package, and then I'll put homework linked list in that new package. So, new package, test match brackets, new class. Let's see. Um, Wait, log. So I think if I select everything, okay, good. That's formatted nicely. Okay, so there's this node storing a head, and then toString, basically putting new lines, like see down here. How to add nodes and add nodes with data, and then okay. So make the following adjustments to the class homework linked list. Homework linked list as shown above. Add the method add head to the class shown above. This method should simply add a new element to the beginning of the linked list instead of the end. Okay, so for example, with like currently we can go from say this, and we can, or maybe this one, we can go from there and say add that. What we want is maybe I want to do go from here, say add 0 at beginning to go to that. Add the method search list to the class. Okay, so let's go to add head in try to. Basically, I'm setting I'm creating a new node, and then I'm saying that next, the new node has points to the head, and then I'm saying the head equals the new node. List of the class above. The method should return true if the user's specified object is found, and false otherwise. The method must be recursive. Okay, so here it is, search recursive. So if it's null, you say it's not there, and basically if you found it, then return true. Now for searching through it, Or search recursive. I think this should. Oh, okay, it's calling. So it says, "Did I find it?" And then it moves on to the next one. Um, so it's kind of like looping. It's kind of like saying, maybe I'm searching for 5. I start at 1. Is 1 5? No. Is 2 5? No. Move on. Is 3 5? No. Is 4 5? No. Is 5 5? Yes. Check. Now say I had chosen 10 and the list ended at 7. I would say, is 5 10? No. Is 6 5? I mean, is 6 10? No. Is 7 10? No. Is null 10? Well, now that we've reached null, we know we haven't reached it. Okay, add the remove method described in the lecture notes. Okay, so we want to remove a node. So this one's kind of more involved. So basically, what else to happen is, like, say with this one we want to remove 1, then we would end up with that. And so what we need to do is say 0 points to 2 now. So at the end we remove the node. So class student that has members variable string and house string takes names and houses inputs, implements the toString method, and implements the equals methods to find two strings to be equal if they have the same name. Okay, here. Okay, so there's constructors, null constructor, and then the toString method is override, and then we just say, okay, do they have the same, does the name equal the other student's name? Okay, homework linked list test, so we define one, create one that holds student objects. Add a new student, add a new, at the end, at the head, remove student, search for student, print all students. And wait, MU linked list? It's homework linked list. That's an error. Let me edit that. Stop editing text. So here, basically saying, depending on what you enter, it will call the various methods. So let me demonstrate running it. So let me print what there is right now. See what we got. Okay, there's nobody. Okay, so I'll add a new student to the end. I'll say Harry Potter and Gryffindor. I misspelled Gryffindor. Let me remove the student and re-add it. So student self, one of the other ones, Ravenclaw. Whoops. Okay. It's bigger here. Um, so We'll add, what should I add? So I've demonstrated that 1 is working. Now for 2, add a new student to the head. Do my father. See, now my dad's at the beginning. I'll demonstrate that a few more times. It seems to be working. Now, say I want to remove a student. Say I want to remove Brad Smith. So I'll do 3, remove a student. Brad Smith is gone. Search for a student. So say I want to search for myself. And then if I search for a student, one that doesn't exist, so say my sister, not added her yet, says student not found. And again, we have print all students, and then quit. Okay. So